Well, hello, welcome to lesson 7.2, properties of a rhombus. Now, there are three special types of parallelograms, all right? There are rhombuses, rectangles, and squares. Today, we're going to focus on rhombuses, but don't forget, there are rectangles and squares, but we're saving that for next lesson. That's for next lesson, okay? Now, a rhombus is a special kind of parallelogram. And there are three ways to know if a parallelogram is a rhombus because it has its three special properties, which we're going to learn about right now. Now, let's go over these three special properties. Let you know that it is a rhombus. So first, a parallelogram is a rhombus if all sides are congruent. So if I know that all the sides are congruent, then this must be a rhombus. So BC is congruent to CD, which is congruent to AD, which is congruent to AB. So if all sides are congruent, then we know that this parallelogram is a rhombus. All right, it's special. Now remember, regular parallelograms, only opposite sides are congruent, but in a rhombus, every single side is the same length. Just to give you a little more background, if this was 5 inches long, then this side would be 5 inches, then this side would be 5 inches, and this side would be 5 inches. They'd all be 5 inches long because all sides are congruent. You get the point. Now the second thing we know is that a parallelogram is a rhombus if the diagonals are perpendicular. So my diagonals are BD and CA. If BD was perpendicular to CA, which is the other diagonal, then we know that this must be a rhombus, okay? So if the diagonals are perpendicular, meaning they all create 90-degree angles right here, then we know that this must be a rhombus. Okay, so we got two properties. All sides are congruent and diagonals are perpendicular. And the final one is a parallelogram is a rhombus if diagonals bisect the vertex angles. And let me be clear here. Bisect means to cut into two congruent halves. All right, so basically you cut it in halves, but the two pieces are congruent. So what that would mean is that this diagonal right here, so this is BD, it cuts the angle into two congruent pieces. So this is congruent to this, and this is congruent to this. Also, the other diagonal must cut the other angles in half. So this is congruent to this, and this is congruent to this. So what that means is that if this is 50, so let's say this angle is 50. Sorry, if this whole angle was 100, let's say angle B was 100, this diagonal will cut it into two congruent pieces. All right, cuts into two congruent pieces. And don't forget, opposite angles are congruent. This is still a parallelogram. Also, let's say all of C was 80. The diagonal will cut it into half, and this would be 40, 40, 40, and 40. All right? So diagonals bisect the angles. So if we know that ABD, so ABD is this angle right here, is congruent to CBD, which is this angle right here, and ADB, which is right here, is congruent to CDB, which is right here, then we know that the diagonal bisects the angle, and this must be a parallelogram. And this also works for the other angles. If these two are congruent and these two are congruent, then we know the diagonal bisects the angles, and so it must be a parallelogram. So these are the three special properties that you must know for a rhombus. All right? So don't forget, a rhombus has all the properties of a parallelogram, because it is a parallelogram, plus it has the three special ones that make it special. I guess I'm being redundant there. All sides are congruent, diagonals are perpendicular, and the diagonals bisect the angles. All right, so let's go into a few proofs right here. All right, so for our first one, it says in parallelogram ABCD, we know that angle BAC is congruent to DAC. So this angle and this angle are congruent. And we also know that DCA, which is right here, is congruent to BCA, which is right here. Prove that ABCD is a rhombus. All right? So we know it's a parallelogram, but how do we prove it's a rhombus? Well, if you see right here, since this diagonal bisects the angles, meaning cut into two congruent pieces. This and this are congruent, and this are congruent. We know it's a rhombus. Using what property? Parallelogram ABCD is a rhombus because the diagonals bisect the angles. Okay, there we go. The diagonal bisects the angles. That means this must be a rhombus. All right, let's try another proof. In quadrilateral MNOP, diagonal OMO is perpendicular to NP. Prove that parallelogram MNOP is a rhombus. So that's a 90-degree angle because we know that they are perpendicular to each other. And all the angles must be right then. So how do I know that this is a parallelogram? Well, parallelogram MNOP is a rhombus because the diagonals are perpendicular. All right. If it has any of these properties, we know it must be a rhombus. Okay? And let's try our last one right here. In parallelogram WXYZ, WX is equal to ZY, which is equal to WZ, which is equal to XY. That's a mouthful. We want to prove that WXYZ is a rhombus. Well, you'll see here it's not drawn, so let's draw it ourselves. Okay? So we have WXYZ. And we know WX is congruent to ZY, which is congruent to WZ, which is congruent to XY. They are all congruent to each other. So how do I know this is a rhombus? Well, this is a rhombus because let's be clear here. Parallelogram WXYZ is a rhombus. Now we have to say what property we used, because all sides are congruent. Nice. All right, and for our last one on this page, which of the following statements proves that parallelogram DEFG is a rhombus? Now, I'll tell you right now, this is a very typical kind of Regents problem where they give you all this information, and what you need to do is figure out which one of these proves that's a rhombus. So what we're going to do is I want you to translate the property that each one of these is. All right, so we're going to translate this into actual words. So for our first one, it says that E is congruent to G and D is congruent to F. All right, so the whole angle E is congruent to angle G and angle F is congruent to angle D. So the property that you see right here is that opposite side angles, why would I put sides? Opposite angles are congruent. Now, is this a property that proves that it is a rhombus? No. Why? That's the property of a parallelogram, so we know this is a parallelogram, but this doesn't prove that it's a rhombus. I need a special property, one of the three special properties that we learned about. All right, so that's not correct. All right, and like I said, it's really important that you translate onto these. The next one is that EG, which is right here, is equal to DF. So this is diagonals are congruent. All right, that's what it's telling me, that EG is a diagonal and DF is a diagonal and that they're the same. So this is telling me that diagonals are congruent. Is that a property of a rhombus? No, so that's not going to tell me that this is a rhombus. And let's try this last one. EF is equal to 4, FG is equal to 4, DG is equal to 4, and ED is equal to 4. And what this tells me is that all sides are congruent. And this is one of the properties of a rhombus, that all sides are congruent, so the answer is 3. This proves that the parallelogram is a rhombus because we know that all of these are congruent. All right, so whenever you're doing a problem like this where it gives you 4 options, write down the property underneath and make sure that it's the property that proves the quadrilateral that you're looking for. Okay? Because these are all true, so opposite angles are congruent. That's true for parallelograms, but it has to be special for a rhombus. All right, so let's get to filling out some angles. This is my favorite part. All right, we're going to fill out for all the angles in a rhombus, and it's pretty straightforward. You'll see. So in WXYZ, we know XWY is equal to 55, okay? And that's put in right here. So XWY is 55. Fill out the chart below for the missing angles. Justify your answers. Well, let's just go through it. So the first one I'm going to do is angle 1, and that is also 55 degrees. Why? Well, since I know this is a rhombus, I know angle 1 is 55 degrees because the diagonals bisect the angles. All right, so if this is 55, this must be 55. It cuts the angle in half into two congruent parts. These must be the same. Okay, so now for angle 2, well, this also must be 55, and this must be 55. So angle 2 is 55. Now this is the same thing as last time. Now you might remember, since these two lines are parallel, I know angle, and these two lines are parallel, sorry. I know that these two angles are opposite interior angles, alternate interior angles. So angle 2 is 55 because alternate interior angles are congruent. The same thing could be said about this angle right here. I know over here 55 is congruent to angle 3 over here because alternate interior angles are congruent. Okay? Now the question is, how are we going to find out angle 4? Well, check it out. So right here we have a triangle, right? And we know that two of the angles are 55 degrees. To find out the missing angle, all I have to do is 180, let's do it in here, 180 minus the two angles, right? Minus 55 is 55, and that gives me 70 degrees. So angle 4 is 70 degrees, and that's the triangle sum theorem that I used. The triangle sum theorem. Right? Because, what's it called? Because this is a triangle, and 180 minus the two angles equals the missing angle. And then angle 5 must also be 70 degrees. And why? Well, this is a parallelogram, so opposite angles are congruent. Why can I use parallelogram properties? Well, rhombus is a parallelogram, so I can use these properties. The opposite angles are still congruent. All right, let's move on to the next question. All right, in rhombus ABCD, angle BCD is 84 degrees. Fill out the chart below of the missing angles and justify your answers. All right, this is just like before, but now we have two diagonals. Let's do it. So angle BCD, which is the whole angle BCD, this whole angle is equal to 84 degrees. And I'm going to put it on the outside because it's telling me, be very careful, BCD is the whole thing. Now, the first angle that it wants me to find is DCA, which is right here, DCA. And that's pretty easy to find. And the reason is, I know that the diagonals bisect the angles. So if the whole angle is 84, all I have to do is cut it into two congruent pieces, and what you get is that this is 42 and this is 42, right? Because the diagonal cut this angle in half. So DCA is 42 degrees because diagonals bisect the angles. Then I want to find ADC. Now this is where it gets a little more complicated, okay? Now excuse me while I erase just a little bit of these markings so I can make it more clear for you. This one wants me to find ADC. Now, don't get lost here, but I'm going to show you how it's done. If this is 40, if this whole angle is 84 degrees, well then how am I going to find this whole angle right here? All right? And the way you're going to do that is, you might remember that consecutive angles are supplementary. Yep, you might remember that. So these two angles are consecutive angles, so I can still say 180 minus 84 is equal to 96 degrees. So this whole angle is 96 degrees, and that's because consecutive angles are supplementary. And then finally you have BDC. That's the last angle I have to find. That's this angle right here, BDC. And if this whole thing is 96 degrees, remember, it cuts this whole thing in half. So if 96 divided by 2, that's going to be 48 degrees and 48 degrees. And this is also going to be, I'm just going to fill these out. So 48, and that's also because diagonals bisect the angles. Now I'm just going to be clear here. We can actually find out the rest of these angles. So remember, if these are 42, across are also 42. All right, the opposite angles are going to be congruent. And this is 48, and this is 48. All right, and also I can find out these middle angles, because remember, these are all 90 degrees. So these all equal to 90. So that's how you find all the angles in here. All right. And finally, this is our last challenge problem. We know that IJ and HK intersect at point L in rhombus HIKJ. HK, this whole thing is equal to 12, and JI is equal to 16. So this whole thing is equal to 12. Our whole diagonal, and our whole diagonal here is equal to 16. Find the length of HI and state the property used to solve it. So this is an interesting problem, and I'm going to show you how to do it. So if you look here, right here we have a triangle. All right, and it's a special kind of triangle because it's a right triangle. Because remember, if this is a rhombus, we know the diagonals make a 90-degree angle. Okay? Now I'm trying to find HI, which is x. And I actually know these two sides. Now remember, the property of a parallelogram that we know is that the diagonals bisect each other. So if this whole thing is 12, this is 6, and this is 6. And if this whole thing is 16, this is 8, and this is 8. Remember? Because the diagonals bisect each other. So this is 9 degrees, this is 6, this is 8. We now have a right triangle right here. So to solve for x, all we have to do is use the Pythagorean Theorem. A squared plus b squared is equal to c squared. Opposite the 90 degrees is our c, so our c is going to be x squared. So it's 6 squared plus 8 squared is equal to x squared. 36 plus 64 is equal to x squared. 100 is equal to x squared, and 10 is equal to x. So HI is equal to 10. All right, just a little Pythagorean theorem then. The properties that we used, well, the first property used is that diagonals are perpendicular. And the second property we use is diagonals bisect each other. And that's it for this lesson. Now, yep, I'm telling you, all these lessons are going to be long. I know we're at 18.5 minutes, but it's a tough unit. I warned you. All right, guys, go to bed. I know it's late, or maybe you're in class, but still go to bed. No, wait, don't go to bed. Stay awake. Never mind. Just